So here if I ask anyone to calculate the area under the curve, so instead of finding the value from minus a to a for a function f of x, for which actually I have drawn this curve, if he is a smart guy, so he will prefer to calculate the value from 0 to a. One side value he will calculate first, and then after that, if it will be multiplied by 2, it will give you the same value what you will get after evaluating minus a to a fx dx. So this is the advantage of even function. You do not require to calculate the value from minus a to a. You just calculate it for one side from the positive side and make it double. It will give you the same value. But you need to remember one point. The point of the interval, it should be at the equidistance from the origin. It must be equidistance from the origin. Now let me to check what advantage actually we are getting if you solve the Fourier series with the help of even function concept. So let me to restrict on f of x by taking it as an even function. This is what even function. So if f of x is an even function, the Fourier series expansion for the full range is given here. This is defined for minus pi to pi interval. Here for sake of convenience actually I have taken the interval from minus pi to pi, so that you will get the end point at the equidistance from the origin. So this is what, since the end point at the equidistance from the origin and the function is an even function, so therefore by this property we can rewrite it like 0 to pi, and this is what f of x dx, you need to multiply it by 2. So therefore this is the value of a naught. Now coming to the value of an, f of x is an even function, cos is also an even function. So if you multiply two even function, so it behaves like multiplying two positive values. So if you multiply two positive value, what we get positive value. Similarly here, even function, if you multiply two even function, it will always give you an even value, even function. So therefore ultimately what we are getting inside this integral, we are getting an even function, and the limit is still at the equidistance from the origin. So if you solve, then it will give you what? It will give you 2 times. So let me to make a correction here. What we are getting for an, we are getting 2 by pi, and this is what this is. You'll have to make a change here. This is, now you need to take only a one-sided graph 0 to pi. So therefore this is all about an. But if you go for finding the value of bn, and by taking f of x, there is a restriction. We can't change this value. Fx is an even function, and sine is what? Sine is an odd function. Later on, once we'll discuss something about that your sine function, then you'll come to understand what is the sine function, why we are writing here odd. So right now actually I will just request you to please remember sine is an odd function. And what is fx? Fx is taken an even function. So even into odd, multiplying even with odd functions, just like plus into minus. So plus into minus gives us minus value. So similarly here, even into odd, if you multiply, then it will give you an odd function. So ultimately what we are getting inside, we are getting an odd function. So if it is an odd function, then it will give you 0. So what we are getting here, bn is equal to 0. So if you put this value here in the Fourier series expansion, since bn is 0, so therefore this value will be removed from the Fourier series expansion. We're left only with fx is equal to a naught terms, along with that your cosine function in terms of infinite series, and here you will remain only with a naught and an. Bn will be equal to 0.